How to work with datasets and SynMap modules on the Syntelli platform. The Datasets module provides a key interface for working with chemical and biological data samples on the Syntelli platform. It allows you to analyze the chemical space of the compound sets of interest and predict the physiochemical and biological properties of the compounds using platform models. The module also allows you to work with search results or optical recognition of structures by the PDF2Smiles module. The Datasets module is loaded when the corresponding tab of the left menu is selected. After loading, we see examples of thematic datasets collected by the Syntelli team. They are ordered by the number of structures. In particular, a generic Syntelli database of over 150 million compounds is presented herein, along with examples of structurally homogeneous datasets of varying sizes for molecular targets, structure classes, and therapeutic indications. These datasets are available to review the structures contained within them and the basic capabilities of the platform models. Different colors on the chart show the safety parameters of the molecule in terms of toxicity, physiochemical, biological, and environmental properties. If the Syntelli predictions for combination are already calculated, they will different colors, if not already gray. Cheat sheet help for handling molecules in the dataset is available in the Hot Tips tab. Any of the thematic datasets can be copied into a private user space to gain access to the full dataset functionality. For this purpose, you need to open the dataset, select all molecules, and then click the Create or Move button to select an existing or create a new dataset. Create your own copy of the dataset with Inderubans. Enter the name in the line, click on Create New, select the appropriate line and go to it. A copy of the dataset with Inderubans has already appeared in the Private User tab for handling your own datasets. The buttons Create Set and Refresh Status are always available. When creating a new dataset, you can enter molecules using the Smiles line, draw one at a time in a molecular editor, load from a file, or search by synonyms. Load GSK3 kinase inhibitor molecules from the SDF file. Once loaded, you can edit the name of the new dataset. To make other functions available, select one or more datasets while holding down the Control key. Options are provided for copying and deleting one or more datasets, combining several datasets, mapping using the SynMap module, as well as exporting a dataset and calculating a complete set of properties for one dataset using platform models. In any dataset, you can add or remove individual structures manually. By selecting a few structures, they can be cut and saved to a separate dataset. To calculate properties for a dataset, you can use the Calculate Properties button. While the calculation is in progress, it is possible to visualize the chemical space of the datasets using the SynMap module. Next, let's take a closer look at this module. When the properties have been calculated, you can return to the workspace and export the data for further analysis using spreadsheet tools. Export is available in SDF and CSV formats. For example, a CSV file contains Smiles connection strings and calculated prediction values by all platform models. Let's go to the SynMap module and consider its functioning in detail. As discussed earlier, the Datasets module provides tools for handling individual molecules and datasets. However, it is more convenient to analyze the underlying regularities in structure-activity relationships using the chemical space maps available in the SynMap module. Open the dataset of GSK3 inhibitors, which we considered earlier. Click on the plus sign next to the Layers button. It is possible to access a selection of datasets from a single list, both thematic and private. Any number of datasets can be selected. The SynMap module projects chemical compounds onto a two-dimensional chart so that chemically similar compounds appear next to each other and chemically diverse compounds appear in different areas of the chart. When you hover the mouse cursor over a point, its coordinates are displayed and the corresponding chemical structure is visualized. For example, dense clusters contain series of closely related compounds, whereas sparse clusters may contain compounds of different classes. Thus, it is possible to quickly get a visual understanding of the chemical diversity of compounds in a dataset, as well as compare two different datasets. Add the indirubins dataset to the chart. These are compounds similar in structure to some GSK3 inhibitors. These will end up in the corresponding sparse cluster, while indirubins with long aliphatic tails will be distant. A 3D representation of the data can be downloaded for more detailed analysis. In this case, clustering may be more efficient and chemical classes that are close in the two-dimensional representation may separate. To rotate the chemical space, you need to press the orbital rotation button, and you can scale the view by rotating the mouse wheel. The indirubins form a dense group here, generally separated from the bis-al malamides, and most of the indirubins from the thematic dataset are also in it. Let's go back to 2D mode and look at the other chart features. Hide the indirubin dataset by clicking on the button with iImage on it. Any area can be selected using rectangular or shaped selection. In this case, the molecules that are included in the isolation will be displayed in the list. It is possible to analyze them visually, to work with them individually, in particular to calculate forecasts using SINT-LE methods, or to save them to a dataset. To deselect, double-click in any area of the chart. The SynMap module also generates new structures that resemble those already projected onto the chart. This function allows you to quickly expand the chemical space of promising classes of compounds. Generators must be added to generate connections. It can be named, selected the parent generation of structures, and the number of iterations or epochs of generation. Without additional constraints, arbitrary compounds will be generated, but SynMap allows an additional wide set of constraints to be imposed on structures: chart area, drug similarity, boiling or melting points, toxicity, lipophilicity, solubility, and so on. All these constraints are calculated based on SINT-LE models. The most important constraint is the map area, or mmap. An arbitrary area may contain connections with unexpected properties or structures, especially if this area is not populated. Therefore, to generate analogues, it makes sense to choose a region populated, for example, by compounds of the same class. To select an area on the map, click on the button in the upper right corner. Select the region in which the pyrazolopyrimidine compounds are located, reduce the radius, and start generation. The resulting connections are in a separate dataset. They can be visualized based on proximity to the original query, selected and saved to a dataset. It is also possible to regenerate based on already obtained structures, adding new constraints to them. For example, on drug similarity, it is better to make it high. The generated connections can be placed in a separate dataset and processed by SINT-LE models. This completes the introduction to datasets and SynMap modules on the SINT-LE platform. See you next time.